Hey guys, welcome to this amazing platform of PW. My name is Rishabh, your physics teacher, and in today's lecture we are going to have one short revision of light, reflection and refraction. So guys, in this chapter we will be starting with all the topics like plane mirror, spherical lenses, power, refraction. All these topics will be covered in this lecture. So guys, starting from the four main topics, we will be starting with the reflection of light first. How light is reflected from various surfaces, from plane mirror, from plane surfaces, laws of refraction. We will be discussing in this topic. Then we will be moving to the spherical mirror and its image formation. Like we have concave mirror, we have convex mirror. How do they form the image? How do we calculate the image distance, object distance? All those things will be covered in this topic. Then we will be moving to the refraction of light. Refraction means bending of light. When light passes from one medium to another, its medium changes, its speed changes, right? So we will be discussing all these factors in very detail. And at last we will be covering with the spherical lenses. How does the lenses form the image? How does light ray bend when it passes through any lens, and lens formula, power, all those things. So guys, this lecture is going to be very interesting, right? We will be discussing each and everything in very much detail. Okay guys, so let's just start with the session now. Excited? Okay, so guys, first is corpuscular theory of light. See, basically in 18th or 19th centuries we had a scientists like Newton, right, Maxwell, many physicists were there, right, who studied the nature of the light. So first of all, Newton was there. He gave us the corpuscular theory of light. Corpuscular means the particles. So he said that when light emerges from any source, this is our sun, so you can see when light emerges from any source, basically it releases the corpuscles. Corpuscles means the particle of light. So for example, when light is emerging from any bulb or any tube light, the particles of light are released, right, because it shows that the light has a particle nature, and those particles are known as corpuscles. Corpuscles means particles of light. So this was given to us by Sir Isaac Newton. Particles of light. So light emerges in the form of corpuscles from any source. So this theory is known as corpuscular theory of light, right? So guys, many phenomena are based on this corpuscular theory. The particle of light are also known as photons. You can also call them photons. Nowadays we call them, basically these are more known by a name of photons, the particles of light. Okay guys, so there are many experiments based on this corpuscular theory or the particle theory of light. For example, solar cell basically works on that photoelectric effect. You will study this effect detail in the higher classes, but that solar cell, what can I tell you at this level is, solar cell works on the particle theory of light, on the photon, this theory of light, right? So many experiments are there which prove the particle theory of light. Okay guys, is it clear now? Okay, so next is rectilinear propagation of light. Rectilinear means travel in a straight line. Rectilinear means travels in a straight line. Travels in a straight line. Now what does this theory gives us? See, let us consider by an example. Suppose you have taken 3 cardboards, right, aligning them in a line, right there with a hole at the center of each of the cardboards, right guys? Now you have placed a candle here and you are observing this candle from here. So guys, you can see, since all the holes are aligned along the same line, the light from the candle is reaching to your eye, so you can see the candle. Basically you can see the candle here, right? But if I talk about any other ray not passing through this hole, so you can see you won't be able to get this ray. This ray is not reaching to you. This ray is not reaching to you. So guys, what is happening, right? You won't be getting the image through this ray. Or you can also call, suppose if I displace this cardboard, let's say if I displace this middle cardboard by a certain distance. So guys, now are the holes along the same line? Now all these holes are along the same line? Obviously not. The holes are not along the same line. So now will you be able to look at this candle if I displace this cardboard a little bit? Obviously not. Why? Because light travels in a straight line, It's not like light travel like this and it will go like this and you can see the candle. No, this won't happen. This won't happen. Okay, this won't happen because light travels in a straight line. This experiment proves that light travels in a straight line. Okay, this is known as a rectilinear propagation. Propagate means to travel. What do you mean by propagation? Propagation means to travel from one place to another. Propagate. For example, light waves propagate. Light from the sun is propagating to the earth. Sound energy also propagate. So this is known as the rectilinear propagation of light. Okay guys, so what is the conclusion? That light always travels in a straight line. Is it clear? So guys, many theories were there given by many scientists. Okay, now let's start with the reflection. Let's our main topic. Now we are heading into the core of this chapter known as the reflection. So guys, you all see yourself in the mirror in the morning. You groom yourselves, right? So how do you see yourself in the mirror? Have you ever thought of that? How our image is formed in the mirror? We all look ourselves in the mirror, in the plane mirror in our houses. So we see that we see the exact copy of ourselves. In the plane mirror, we see the exact copy of ourselves. Right guys? For example, this man is observing his image. This man is observing his image. So you can see we have taken a plane mirror. We have taken a plane mirror. So have you ever thought how does this image forms, this mirror forms the image of this man? This is our object. This is our object and this is the image. This is the image. So how does this mirror form the image of this object? Have you ever thought of this? The answer lies in the reflection. The answer to this question is by reflection of light. Light is reflected by this mirror. Light is reflected by this mirror and thus this mirror forms the image basically. So image is formed due to the reflection of light in the plane mirror. It's not, we are not done yet. We will be discussing how is the rays formed, how are the rays meeting. We will also discuss that. Okay guys, so basically what is reflection of light? First we should go through the definition. Reflection of light is the phenomena of bouncing back of light. Bouncing back, right? For example, when I drop a ball from here, it goes down and bounce back to the floor and comes into my hand. So this is the bouncing back, right? If I throw a ball to the wall, it bounces back towards me. So this is how light is bounced back from any surface. Reflection of light is the bouncing back of light in the same medium. Same mediums means, suppose, what do you mean by same medium? Suppose I have taken a plane mirror and to the right I have water, right? And to the left I have air. So guys, if a ray is incident on this plane mirror, it will be reflected in air. It won't go in water. In reflection, light ray comes back in the same medium. It won't go in the water, it is still in the air. So this is our incident ray, right? This is our incident ray. This is our incident ray and this is our reflected ray. This is our reflected ray. So both lie in the same medium. Medium doesn't change in reflection. It changes in refraction. We will study this later. Okay guys, so incident ray and reflected ray both lie in the same medium. This is what is meant by refraction, right? And how does light ray reflected when it strike a surface of any object guys? Reflection does not depend on the object. Every object reflects the light. This board, this remote, this pen, even I am reflecting some light. That's why you are able to see me. So every object that reflects light, we are able to see that object. Is it clear? So this is known as the reflection of light. Write down this definition guys. Just pause the video, write it down, then replay it. Okay, clear? Reflection of light. Now are there certain laws that are followed by the reflection of light? Yes guys, reflection, we have certain laws for reflection. It's not like we can reflect the light any way we want. There is some law that has to be followed while studying the reflection of light. What is the law guys? See, suppose I have taken a plane mirror or any plane surface. I have taken a plane mirror or any plane surface guys. This is the incident ray. This is our incident ray. Right, guys? This is normal. What is normal, guys? Normal means this is the point of incidence. If I talk about point of incidence, means the point at which incident ray is meeting the surface, this surface. So this is called point of incidence. Point of incidence, guys. So this surface has reflected this light towards this here, right? Towards here. So this is our reflected ray. This is our refracted ray. So guys, basically we have three things. First is incident ray. Second is normal. Normal means any line drawn. I repeat, any line drawn at the point of incidence normal to the surface. Normal means at 90 degree. So if I draw any line 90 degree to the surface at the point of incidence, that line is said to be normal. And this is our reflected ray. So guys, first, what is the first law? What is the first law? First law states that this angle of incidence and angle of reflection, I is the angle of incidence. I is the angle of incidence, guys. I is the angle of incidence. Okay. What is R, guys? R is the angle of reflection. R is the angle of reflection. So basically these two angles are equal. This is our first law of reflection. It states that the angle of incidence is always equal to the angle of reflection. Both are same. If I is 30, R is 30 degree. If I is 40 degree, R has to be 40 degree. It's not like if I is 30, R could be 40, right? If that is happening, it won't be a reflection of light. We won't consider it as reflection of light. Always this law is followed. Clear? Okay, guys. Now what is the next law? This is the first part of this law. Next part is the incident ray, the normal, and to the mirror at the point of incidence. I said 90 degree to the that mirror at the point, and the reflected ray all lie in same plane. Now what is same plane? What do you mean by same plane? Plane means two-dimensional surface. What do you mean by plane? Plane means any surface having two dimensions. For example, this smart board. This smart board currently is a plane surface, right? Or for example, if I talk about the plane of the paper of the your paper in your notebook, it's also a plane surface. If I neglect its width, right, its height, so it's a plane surface. So this is two-dimensional surface. So basically, what is the second? Listen to me very, very carefully. People don't get this. Incident ray, normal to the mirror, and the point of incident, right? And the reflected ray. All these three lie in the same plane. Now, what do you mean by same plane? Plane means all these lie in the same plane. Like I have a wiper of a car. Have you observed the wiper of a car? It moves like this. It won't move like this, na? It won't move like this. It moves in a plane. It moves in one direction, along one surface. So this is the basically thing is incident ray, normal ray. For example, I am moving like a wiper my hand. So I am starting from here. Incident ray, normal ray, reflected ray. Can you see? The motion is in one go, right? It's moving like a wiper of a car. So all these three rays should come in this plane. It's not like incident and in normal I like this and reflected is coming out of the board. It won't happen. All lie, right, like a wiper of a car. Clear? You can remember this second point like this. Okay, so all these three light rays, incident, normal, and the reflected ray, all lie in the same plane. Is it clear, guys? So these are the laws of reflection of light. These are the laws of reflection of light. Clear? Write it down fast. Okay. Now, so most important, plane mirror. Image formation by a plane mirror. So guys, can you observe this cat? Can you observe this cat? See, this is the cat and this cat is observing herself in the mirror. You must have seen many animals like dogs and all those observing themselves in the mirror and getting scared. So basically this cat is observing herself in this mirror. This is our plane mirror. This is what, guys? This is our plane mirror. Okay, so this is our cat, this is our image. Basically this is the image, this is the image. So guys, can you see the motion in the object are same as the motion in the image? The way the cat is moving is same as the way its image is moving. See, the cat is head is coming down, head is coming down, the head of the image is also coming down, right? Can you see it? Right, the motion in the hand of the object and the motion in the hand of the image are same. The hand is coming down, right? You can see the hand will move like this. See, the hand is coming up and the hand of the image is coming up. So basically what is happening, both are copying each other. The object and the image are copying each other in plane mirror. So this is what happens here. This is what happens here. That is, in plane mirror, image and object are what? Are replica of each other. Are what? Are replica of each other, means copy of each other. They both will copy each other. For example, obviously when we look ourselves in the mirror also, the image and the object are copy of each other, right guys? So you can see this is what happens in the plane mirror. So plane mirror creates the exact replica, the exact copy of the object. Is it clear? Okay. So guys, okay, we have another sir now. Oh, right, one more Rishabh sir, even two more Rishabh sir. So guys, this is myself, right? This is real me. This is the plane mirror. I am observing myself in the plane mirror. I am observing myself in the plane mirror. Now I will tell you the characteristics of the image formed, right? So guys, can you tell me, see, I am looking forward in the plane mirror like this. So I am looking to my right hand. This is my right hand. This is my right hand, right? This is me and this is my right hand. But guys, if I talk about my image, so you can see my right hand has become my left hand in the image. This is the left hand of my image, na? Right hand, my right hand has become my left hand, right? And my left hand will become my right hand. So what is happening? Right and left are reversing. Right and left are reversing. So guys, this is known as lateral inversion. Lateral inversion. So this is what happens in the plane mirror. The image is laterally inverted, right to left and left to right, right to left or left to right. So this is what happens in the plane mirror. This is known as lateral inversion, right? So this is the first characteristics of the image formed by the plane mirror. There are many more characteristics. We will study that. Is it clear? Okay. So the image is laterally inverted. Now we have another Rishabh sir. So guys, now I'm about to tell you how my image is formed in the mirror. See, I have taken two rays, one from my head, right? So basically this ray is normally incident, so it will retrace its path. Another ray will be reflected, right? This is our angle of incidence, normal. With the normal, this is angle of reflection and both will be same. So guys, these two rays are not meeting here, but if I back extend them, you can see the image of my head is formed here. See, image is formed where reflected rays meet. Let me tell you one thing. Image is formed where reflected rays meet. People sometimes get confused. Where reflected rays are meet, where reflected rays are meet. Image is formed at the point where reflected rays are meet. Similarly, if I talk about the ray from my toes, so again same rays, and you can see my image is formed here. So my complete image is formed like this. There are many rays coming from my body parts, from my body, and therefore their images, corresponding images formed by the mirror. So this is a basic example of how plane mirror forms our image. Okay guys, clear? Now notice one thing. This is object, basically this is real me, right? This is the object, okay, and this is the image. This is the image, right? Sorry, it's virtual, or I must say it's image. I will tell you the meaning of virtual, don't worry, right? It's image. So guys, basically we have two parameters. One is object distance, another is image distance. What is object distance? The distance of the object from the mirror is known as object distance. I repeat, the distance of the object from the mirror is known as object distance, and the distance of the image from the mirror is known as image distance. So guys, in case of plane mirror, can you notice one thing? That object and image distance are same. They are equal. That is, as the image is formed as far behind the mirror as the object is in front, right? Have you observed, suppose you are standing in front of a plane mirror. So do this right now. If you move away from the mirror, your image will also go away from you in the mirror. If you move yourself away from the mirror, right, so your image in the mirror will also go away from you. Or if you are moving towards the plane mirror, your image will also move towards you. Have you observed this, right, in the mirror? So that means image and object distance are equal. They are changing equally. So this is the second characteristics. Image distance and object distance are same in case of plane mirror. Now there is one more thing. Basically, this image is called virtual image. This image is called virtual image. Now what is virtual image, guys? What is virtual image? Let me tell you. See, basically what happens is, if I talk about reflected rays, these two rays will never meet here because they are diverging, the reflected rays, right? They won't actually meet. But if I back extend them, I can see the image. So guys, this is the virtual image. Virtual means behind the mirror. The image is formed behind the mirror. The rays are not actually in meet, but the rays appear to meet, right? If I am looking over this ray, suppose I am looking myself, or somebody is looking at me from here, so he will see me here, he will see my image here. So basically it's a virtual image, right? He will see me here. It's a virtual image. The image is formed behind the mirror, first thing. Second is, rays won't actually meet. This is the case, right? But if the rays actually meet, this is known as the real image. We will see the real image in the coming spherical mirrors, but for this plane mirror always forms the virtual image. Can't be taken on a screen. You cannot take this image on the screen because it's virtual. Okay guys, is it clear? Fine. And one more thing, am I magnified? This is the height of real me. Can you see? The height of myself and my image are same. Can you see one more thing? My height and my image height are same, and that is obvious. When we see ourselves in the mirror, our height is same as the height of the image. Both are equal in height. It's not like my image is magnified. It has become too large and has gone too small. This does not happen in plane mirror. It too happens in spherical mirrors, but it does not happen in the plane mirror. They form the same size image. Is it clear, guys? Now let's write down all the points. Write down all the points, guys. First is, image formed by plane mirror is always virtual and erect. Now what do you mean by erect? Erect means the object is like this and the image is also formed like this. It is not upside down. If my head is upwards, obviously the head of my image is upwards, right? It's not like my image will be inverted. It won't get inverted. Is it clear, guys? So image is always virtual and erect. Next point is, the size of the image is equal to the size of the object. Object height and image height are same. What is the meaning of this point? Is that object and image height are same. Object and image height are same. Is it clear, guys? Is it clear? Okay. What is third? The image formed is as far behind the mirror as the object is in front of it. That is, object distance is equal to the image distance. Clear? And what is the last? Image is literally inverted, right to left and left to right. So guys, these are the 4 properties of the image formed by a plane mirror. Is it clear to you? Is it clear to you, everybody? So just write it down, pause the video and write it down. Then we will move on to the next topic. Clear? Shall move forward now? Okay. Try this question. Read it guys. Question is, a ray of light is incident on a plane mirror and gets reflected, right? The angle between, read it carefully, the angle between the incident ray and the reflected ray is 120 degree. The angle between incident and the reflected ray is 120 degree. What you have to find? What is the angle of reflection? You have to find the angle of reflection. Try it. Just pause the video and try it. First, you should try the question by yourself. Then look over the solution, right? So guys, let me draw a diagram. Diagram is must. The more clear you draw the diagram, right, the more you will be able to get the correct answer. So basically this is the incident ray, right, and this is the reflected ray. Now it has been stated the angle between incident and the reflected ray is 120 degree. So guys, this angle is given as 120 degree. This is angle of incidence, this is angle of reflection, this is normal, this is I, this is R, and the total is 120 degree. That is, guys, if you look from the figure, angle I plus angle R is 120 degree. Okay guys, now I is equal to R. Yes, can you recall the law of reflection? I is equal to R. So guys, this will be twice of I is equals to 120 degree. So guys, what is I here? I is 120 by 2, which is 60 degree each, and this will also be equal to R. So I and R are both equal to 60 degree. Clear? So what is the correct option? Option B. I and R both are equal to 60 degree. Clear guys? Very basic question. Clear? Write it down, then we will move on. Okay, chale, let's move on. Now this was a basic thing about the plane mirrors, but are there always plane mirror available to us? It's not like that. Thing is, sometimes we need to magnify the image, guys. It's not like we always want the same size image. Sometimes we need to magnify the image. Magnify means either too large image or too small image. So how does it can happen, right? How does it happen basically? Thing is, suppose if can you look at it, the view of the complete field is taken in this small mirror. Can you see it? This view of this complete ground is taken in this small mirror. Now obviously it won't be plane mirror, because you cannot taken the field, this complete field, in small mirror. The mirror would have been very huge, right? But it's a small mirror and you have taken the view of the complete field. So guys, such mirrors are called spherical mirror. Spherical means their surface, their reflecting surface is not plane. They are spherical, they are curved mirrors, or they basically magnify the image. So we can get the magnified image with the help of plane mirrors, spherical mirrors. So what is the definition, guys? The reflecting surface of such mirrors can be considered to form a part of the surface of hollow sphere. Basically what happens is, if you take a hollow sphere, guys, suppose you take a hollow sphere, you cut it from here, right? Obviously now you will be getting a part like this. Now if you polish from outside, it will act like a mirror. Basically what you have done, you have polished it. This is the polished surface. Therefore if this is the polished surface, this will be reflecting surface, guys. Can you see it? This will be reflecting surface. So such mirrors are called spherical mirror. They are formed from sphere. They form a part of the sphere of glass when you paint it, right? And next is, for such mirrors, image size may or may not be equal to object size. Image can be larger than object, image can be smaller than object, image can also be equal to object. So you can get a variety of images from these spherical mirrors. Now we will be studying about these spherical mirror in very detail. Is it clear? Write it down, guys. Okay, so we have two types of spherical mirror. As I had said, if you cut the glass sphere, either you can polish inside or you can polish outside, right? Here you have polished inside, here you have polished outside. So this is the reflecting surface here, and here this is the reflecting surface. So you can see reflecting surface are different. Here it is inwards, here it is outwards. So guys, based on this we have two types of spherical mirrors. First is concave. Concave means it has inner reflecting surface. The reflecting surface of concave mirror is inner, but for convex, outer surface is reflective. Outer surface is reflective, inner is polished. Here inner is reflective, outer is polished. Is it clear, guys? So we have two types of mirror. One is concave, other is convex. So how can you remember this? Concave means cave, like a cave. It is bulged inwards. It is bulged inwards. The reflecting surface is bulged inwards. But here the reflecting surface is bulged outwards. It is bulged outwards. Is it clear, guys? So we have two types of spherical mirror. Now we will be studying the property of each of the mirror in very detail. So guys, basically there are certain terms. Before going, see, we have gone through the definitions. Now we have to study the image formation. That's why we are going through this. So but before studying the image formation, there are certain terms that needs to be cleared, right? So those terms we will be studying now. First is aperture. What is aperture? It is the diameter of the reflecting surface of spherical mirror. Diameter, guys. For example, if I take two mirrors, let's take an example. This is the first mirror and let's say this is the second mirror. So guys, what do you think? Which will reflect more light? Obviously this one. This can reflect, or this can gather more light, right? This can gather more light. Here we have less reflection. This can gather more light, right? Therefore it has more reflection. Here we have less reflection. So guys, this term this is defined by the aperture. Aperture means the reflecting area, the reflecting surface area, the reflecting surface area. This is known as aperture. How much is the reflecting, the effective diameter of this surface, the affecting area of this surface? Clear? This is known as the aperture. This is how we define the aperture. Okay guys, so more aperture means more light rays will be gathered. More light ray will be gathered means the image will be more bright, more clear. So have you seen that that Hubble, very large mirrors, the to observe the space, they are very huge. Why? The mirrors and lenses are very huge. The Hubble telescope, and we have many telescope in USA. So basically their effective diameter is very large. Why? To gather as much light as they can. For example, we had observed the image of black hole few years back. You must have all seen that. So basically to observe that, we have a very high technological telescope, very high effective aperture telescope for that, right guys? To gather many rays and so as to get a clear picture of that. Okay guys, next is center of curvature. So guys, I had told you this spherical mirror is formed from a glass sphere. So guys, this glass sphere must be having some center na? This glass sphere must be having some center. So this center is known as the center of curvature, or the radius is known as the radius of curvature. So what is center of curvature? The reflecting surface of a spherical mirror forms a part of a sphere. It is formed from the sphere, and the center of that sphere is known as the center of curvature. Is it clear? Right? It is a center known as center of curvature. Now it has to be there has to be some radius also. It has some radius na? This sphere has some radius. So this is known as the radius of curvature. The radius of the sphere of which the reflecting surface of a spherical mirror forms a part. The radius of that sphere, this reflecting glass sphere, is known as the radius of radius of curvature. Clear? Okay guys. Now we have principal axis. What is principal axis? See guys, basically, see, before studying the principal axis, let me tell you few more terms, then you will get it more clearly. Principal axis. Now next is principal focus. principal focus. What is principal focus, guys? See, suppose if I take a concave mirror, okay, and some rays are coming parallel to principal axis like this. Rays are coming parallel to principal axis. So guys, after reflection from the mirror, they will meet at a point. They will meet at a point, right? This point is known as the principal focus, where parallel rays converge. This is known as the converging mirror, right? You can see it is converging the rays. This is known as the converging mirror. Is it clear? So what is principal focus? A number of rays parallel to the principal axis. Basically, principal axis means this straight line, right? You will get when I will be telling you about the pole, then you will get it more clearly. Basically, it's a straight line. So this green one, these yellow rays are parallel to the green one. So this is principal axis. So when a number of parallel rays are falling on this mirror, they meet at a point after reflection, and this point is called principal focus. Principal focus. Is it clear? Okay. Next is focal length. Focal length means, see, this is F, right? So focal length means this is the pole. This is pole. So focal length means distance between focus and the pole. What is pole? It is the center of the reflecting surface. This, see, basically thing is, this reflecting surface has a center. This reflecting surface has a center, and this center is known as the pole. We denote it by capital P. Is it clear? Okay. So distance between the pole and the principal focus is known as the focal length. Clear, guys? Now what is principal axis? Principal axis is an imaginary straight line. You imagine a straight line passing through the pole and the center of curvature of a spherical mirror. Imaginary straight line. Suppose if I draw any mirror, so guys, basically we have pole, we have focus, we have center of curvature, and this imaginary straight line is called principal axis. The line joining all these 3 points, right? This is called principal axis. These 3 points are collinear, they lie along the same line, and this line is known as principal axis. Is it clear, guys? So these are the terms related to any spherical mirror. So guys, it's not like these are for the concave mirror. You can also have the same terms for convex mirror also, guys. So if I draw any convex mirror, so this is our pole, it is our focus, and this is our center of curvature C. Okay, guys, basically here all lie to the right hand side because center of curvature will be here, na? This mirror is formed like this. Basically, this is formed like this, right? Its radius of curvature lies to the right. The radius of curvature of concave mirror lies to the left. Clear, guys? So these are the terms related to the concave mirror. You should be remembering principal focus, center of curvature, focal length, right? Or radius of curvature, pole, aperture, principal axis, because you will be needing all these things in the image formations. Clear, guys? Okay, write down all these terms. The definition of these terms is asked in the board examination. For example, define center of curvature. I can recall my board examination. I had a question on this: define principal axis. Define principal axis and this defined center of curvature. I can still recall. So that was 3 marker question, I guess. So I had to write down a definition of both these. So thing is, if you write these definitions, you will get full marks, right? Because these are exact definitions from NCERT. Is it clear? Should I move forward now? Write it down. Okay. Now, image formation. Basically, guys, to study the image formation, we should be knowing how to draw the rays, right? Because rays should meet. I had told you where reflected light rays meet, the image is formed at that point. But thing is, how can we take the image? The rays for image formation, we should be knowing that. So guys, there are basically 3 rays that you can take. 3 rays that you can take, which I am about to tell you. First is any ray passing through principal focus. What happens if you pass any ray through principal focus, guys? This is principal axis, this is pole, this is focus, this is center of curvature. If you pass any ray through principal focus, guys, it will become parallel to principal axis, or vice versa. If you pass any ray through focus, it will become parallel to principal axis. Or if you take any parallel ray, I repeat, if you take any ray parallel to principal axis, it will pass through principal focus. So both are same. A ray has to pass through F, simple. Whether it is passing F first or whether it has gone become parallel first, it doesn't matter. Thing is, it should be passing through focus. Clear, guys? Okay. Next is ray passing through center of curvature. So guys, if I pass any ray through center of curvature, let me draw a different diagram for this. If I pass any ray, this is our pole, this is focus, this is center of curvature. I will also draw this for convex mirror, don't worry. So guys, basically, if you pass any ray through center of curvature, it will retrace its path. Why? Because, see, can you recall the plane mirror case? Any ray normal to the mirror retraces its path. We know this. So guys, basically, any ray passing through center of curvature is normal to the mirror. That's why it retraces its path. This is the case. Why? Because this ray is normal to the mirror. Is it clear? That's why it retraces its path. Okay, here angle of incidence is 0, right? Because it is along the normal, and angle of reflection is also 0 for ray passing through C. Just recall this. It is very, very important, can be asked. I and R are 0 for a ray passing through the center of curvature. And the last ray is ray passing through pole. So guys, if I pass any ray through pole, what will happen? If I pass any ray, this is pole, this is focus, this is center of curvature. If I pass any ray through pole, what will happen? It will be reflected accordingly. It's called oblique incidence. What do we call it, guys? Oblique incidence. So any ray passing through the pole will reflect at the same angle. So these are the three rays that you will be considering. Okay, clear? But what about the convex mirror, guys? Let me tell you. If you take convex mirror, I will be telling in the same diagram. This is pole, this is F, this is C. So first is, if you take any ray parallel to the principal axis, it won't go like this. Obviously it's a mirror, it will reflect. So it will reflect it in such a way that it will be appeared to coming from focus. So this is the case here. Second ray is, if you pass any ray through pole, same nature is observed. Next is, any ray passing through center of curvature, the ray is incident on center of curvature, it will retrace its path because all the parameters are behind the mirror. Clear? So this is the case for convex mirror. Let me tell you, this is the case for convex mirror. Okay, clear, guys? This was the case for concave mirror. Clear? Okay, draw this. So keeping this in mind, now we'll be studying the image formation. The main part of this chapter is about to start. Cases of image formation by concave mirror. So guys, before starting with the cases, let me tell you three terms. First is, for every image, we will be considering the image size. How is the image? Whether it is same size, right? Image can be of same size. Image can be enlarged. It can be larger than the object, or image can be diminished. It can be smaller than the object. Let me tell you. So for every case, we have to consider these terms. Second is, whether the image is real or virtual. Real means rays meeting in actual. Virtual means the rays appear to meet. We have to consider this thing. Third is image and object distance. So we have to consider these three parameters for every ray diagram: image and object distance. Clear, guys? Okay, so we will be drawing each and every ray diagram. See why I'm about to do that, because I want you to draw the diagram by yourself. It's not like I would have I would have brought some pasted pictures of here in of the ray diagram, but I don't consider doing that, because I want you to draw the diagram the way I am about to draw. Is it clear? Okay, so these are the three points you should be considering. So case number first, draw a concave mirror like this. Okay, this is pole, mark all the parameters, right? So guys, first we take object at infinity. I will be showing the object by arrow and image also by arrow. So guys, if I take object at infinity, the rays comes parallel. This is the thing, right? So obviously they will meet at the focus. So where is the image formed? At focus. So I denote object at infinity. I will be writing this in short. I means image at focus, right? Image at focus. And how is the size? The image is point size, highly diminished. It is called very, very small, or I can call it image size is point size. Image is point size, right? And whether it is real or virtual, guys, this is real image, because rays are actually meeting. You don't have to extend them, and they are formed in front of mirror. So image is real and inverted. Clear? So this is how we are going to write every parameter. Clear, guys? Okay. Next case is, sorry. Next case, guys. Draw the concave mirror. This is pole, this is focus, center of curvature. Brought the object closer to the mirror. Now this is the object, guys. So first is ray parallel to principal axis. It will pass through focus. Second ray is ray incident on the pole. So guys, here the ray will meeting like this. Wait. Yeah, sorry, my bad. Here the ray will be meeting like this. Clear? This is the first case, right? Second is, here the rays will be meeting like this. This is the second case. So guys, this is image, this is object, this is image, because this is where reflected rays are meeting. So this is object, this is image. So object is we write it beyond C, beyond center of curvature. Image between F and C, between focus and center of curvature. Image is whether it is enlarged of same size or diminished. This is small. Object is bigger than the image. So guys, image is diminished, right? Image is diminished. Is it clear? Image is diminished. And whether it is real, obviously it is real, because rays are actually meeting. So it is real and inverted. Clear? Okay. Third case, guys, just draw it with me. What could be the third case? Bring object now more closer to the mirror. This is pole, this is focus, this is center of curvature. Now object will lie on center of curvature. What will happen? First ray again parallel to principal axis, it will meet here. Okay, second ray is oblique incidence, it will meet here. So guys, you can see object and image are just up on each other here. Okay, so where is object? At C. Where is image? At C. And object, the image here is of same size, guys. Here the image is of same size, right? Here image is of same size. And whether it is real, obviously the rays are actually meeting. If you place screen here, guys, you will get image on this screen. Okay, so here the image is real and inverted. Is it clear? Real and inverted. Okay, clear, guys? Just recall all the cases. Now object will become more closer to the mirror, right? Fourth case, what will happen? Fourth case, guys, principal axis, pole, focus, center of curvature, and this is our object, more closer to mirror. Again same rays will be taken, right? And here again the rays will meet like this. Okay, my bad. Let me draw this again. Okay, so here the rays will be meeting like this, right? Here also. So basically this is our image formed. This is our image formed and this is our object. Clear? Okay guys, so you can see here this is the object and this is the image. This is the object and this is the image. What about the parameters here? Can you tell me what about the parameters? Object is what? Between C and F, right? What about the image? Image is beyond C, right? Whether image is enlarged? Yes, here image is bigger than the object, right? So you can see enlarge image is enlarge image. Whether it is real? Obviously yes, image is real and inverted. Clear? Image is real and inverted. Second last case, fifth one. Second last case. Let me draw both the mirrors here, and this will be our sixth case. Clear guys? This is pole, this is focus, this is center of curvature. Okay, this is pole, this is focus, this is center of curvature. Okay guys, clear? Now object will be at focus, more closer to the mirror. So guys, here the ray will become like this, parallel and oblique incidence. Now guys, you can see these rays are not meeting in actual, these are parallel rays. So what will you write? Object at focus. So guys, what we assume that image are meeting at the infinity, at very large distance. Parallel rays meet at infinity. Okay, so image at infinity, size is highly enlarged. Image will be very enlarged, highly enlarged, and obviously the rate will meet in actual. We see that. So the size nature will be real and inverted. Clear? Okay, now more closer to the mirror. Again, this is the last case. You cannot keep the object beyond, after this obviously. So between F and C, what will happen guys? First is, let me take ray normal to the mirror like this. So it appears to pass through. Let me redraw this again. So basically here you have taken object like this. So if you consider normal incidence, the ray will appear to pass through C. Now if you pass any ray through this pole, it will go like this. So if you back extend these rays guys, what will happen? They won't meet here, like I had told you in the plane mirror. They won't meet here, but if you back extend them, they appear to meet here. So guys, here the case is different. Where is object? Where is object between F and P? Where is image guys? Here image is behind the mirror because it's virtual. Here the image is behind the mirror. Is it clear? Is it clear guys? What about the nature or what about the size? Obviously it is bigger than the object. This image is bigger, right? So it is enlarged. It is enlarged. Clear? And what about the nature? It is virtual and erect. It is virtual and erect. Clear? It is virtual and erect. Size, erect and virtual. Okay, clear? So guys, these were the cases formed by the concave mirror. Now what about the convex mirror guys? Convex mirror has only two cases. If I talk about convex mirror guys, right? So basically convex mirror has only two cases. This is case 1 and here we will be considering its case 2, right? So basically this is pole, this is focus, this is center of curvature. Okay, let us draw the another concave convex mirror. This is pole, this is focus, this is center of curvature. Now here The nature is different, guys. Concave mirror was converging, but convex mirror is diverging. It is diverging mirror. What will happen? If you consider the rays, it will diverge them, like they appear to be coming from F, right? It will diverge them. Clear, guys? So here, where is the object? First case is same. Object at infinity. Where is image? Image at focus, and it is point size. It is point size. And what is the next thing? It is virtual or real? Rays are not meeting in actual, guys. So this is known as the virtual image. Clear? This is virtual and erect. Virtual and erect. Clear? Now bring object closer to the mirror. So again, same rays, parallel, they will appear to be coming from focus and then passing through P, and they will go like this. Now these rays won't meet in actual, but if you back extend them, they appear to come from here. So this is the object and this is the image, guys. This is the object, this is the image. So here also, where is object? Object is anywhere. If you place the object anywhere between pole and infinity, object is between infinity and pole. Where is the image formed? Image will be formed between P and F, between P and F, guys, between pole and focus. What about the size, or what about the nature? Obviously it is also virtual. It is also virtual, erect, and it is diminished. It is diminished. Clear? Is it clear to you? Okay, so these were the cases, guide, of the spherical mirror. So what you can conclude, that image formed by concave mirror has a variety: enlarged, diminished, same size. But convex mirror can only form diminished image and virtual image. So it has its restriction and its own application because of this, or based on this. Clear? Okay, fine. Let's do a question for a recall. Question is, a ray of light is passing through the principal focus after reflection from the mirror. What will happen, guys? If you pass any ray through principal focus, can you recall it? Any ray through principal focus, guys, what will happen to the ray? What will happen to the ray if it passes through focus, guys? I had just told you, it will what? Any ray passing through the principal focus will become parallel to principal axis. I had told you, whether it is concave or convex, it will become parallel to the principal axis. So which option is correct? A, become parallel to the principal axis. Very, very simple question, just for a recall. Clear? Okay, convex mirror cases are done. Okay, I had told you the cases of image formed by a convex mirror. So this is already done. Okay, now applications. How we use these spherical mirrors? Because see, I had told you we had a different variety of images. Concave mirror can form basically both type of images. It can form real image, it can also form virtual image, it can form enlarged image, it can form same size image, it can form diminished image. While convex mirror has some restrictions, it can only form virtual erect image and diminished image. So guys, based on this image formation, we have a variety. So guys, have you seen when a dentist is performing some treatment, he uses some kind of mirror here. So basically you can see the image is zoomed. The image is zoomed, or I can see it is magnified. So guys, what type of mirror it could be? Obviously concave mirror. It can't be convex. It cannot magnify it cannot enlarge the image. It cannot form enlarged image. So this is concave mirror used by the dentist, right? Next is mirror in our headlight of the vehicle. So guys, this we have concave mirror in the headlight of the vehicle. Why is that? Why is that, guys? See, basically what do we want in our headlight? We want the range to be maximum. We want a parallel beam of light. We want the beam to be parallel, so it can go farther away. So guys, what can we do? Basically, if or any ray, basically what we do is we place the bulb. Can you see this bulb? This bulb is placed at the focus here. So guys, when the rays will appear, will emerge from this, they will become parallel to principal axis na, because the bulb is placed around focus. So we get a parallel beam of light. We get a parallel beam of light. A parallel beam of light. Is it clear, guys? Similarly, in dish antennas also, the rays are this receiver is kept at the focus basically. So signals coming parallel will merge here. So it's concave shaped. Clear, guys? This is the application. These are the applications of the concave mirror. Okay. Next is convex. So guys, I had told you in the beginning that you can get the view of this complete field in this small mirror. That means it is forming diminished image. So diminished and virtual erect image is formed by convex. So basically we get a wide field of view. We get a wide field of view. Wide field of view. Clear? Similarly, in the rear view mirror of our vehicles, it has convex mirror. Rear view mirrors in the vehicles, it has convex mirror to get a wide field of view. We can see the complete traffic because of this convex mirror. Clear, guys? Okay. Now next is sign convention. What is sign convention, guys? See, basically we had seen how do we form the image, how object distance is seen, how image distance is seen. But guys, if I ask you, how can you calculate the object distance? Are there any calculations? Obviously yes. There is a calculation for focal length, there is a calculation for object distance, for image distance. All these things have some calculations. So basically before moving into that formula, we should be knowing sign convention. So guys, what is the sign convention? See, we have three parameters. One is image distance. One is image distance. Other is object distance. Other is object distance. Third is focal length or radius of curvature. Focal length or radius of curvature. So guys, these three things have some sign. How? If I take any mirror, now listen to me very, very carefully. If I take any mirror, the pole of the mirror is taken as the origin. The pole of the mirror is taken as the origin. Origin of what? Origin of Cartesian plane. Can you recall it, guys? Origin of Cartesian plane. This is origin. So right hand side we have positive x-axis, left hand side we have negative x-axis, upward we have positive y-axis, downward we had negative y-axis. Same cases here. Distance to the left of pole are negative. Distance to the left of pole are negative. Distance to the right of pole are positive. Distance upwards are taken as positive. For example, object. I always keep the object like this. So object height is positive. If distance is downwards, it is negative. Same to the Cartesian plane. No need to remember. Same as Cartesian plane, the xy plane. Clear? Right? Also we have, you can write one more thing. Also we have image and object height. Image and object height. Is it clear, guys? Okay, write it down. This is very, very important thing you should be knowing, guys. Okay, these are the various parameters. Now keeping this thing in mind, we have two formulas. One is the mirror formula that relates the image distance. V is the image distance. Let me write it down. V is the image distance, guys, and U is the object distance. U is the object distance. And what is F, guys? F is the focal length. f is the focal length. Clear? Okay guys, so what is mirror formula? 1 by f is equals to 1 by v plus 1 by u. This is the mirror formula that relates these three parameters. Now we have formula for magnification. This m is the magnification. It is ratio of image height to the object height. Image height is h dash, object height is h. So mh h dash upon h, or it is also equal to minus v by u. This minus is present in the formula. This minus is present in the formula. So guys, these are the two formulas you should be knowing to calculate any parameter that you want related to the image formed by spherical mirror. Now question is, sir, how can we put the values here? So guys, there is a note for you. Note is, write it down. Put all parameters. Note is, put all parameters with sign here. Just put all parameters with sign. Like f, u, v, image height, object height. You have to put all the parameter with sign. How? Whether it is positive, it is negative, positive, negative. Just look at the figure. Look at, remember, recall all the cases I had just told you, and just put all the parameters with sign. Is it clear, guys? Okay. Now let me tell you how to take the signs. It is very, very important, guys. Thing is, we have magnification, we have image distance, we have object distance, we have focal length, we have image height, we have object height. Now question is, sir, how to recall all the sign convention? So guys, how can you do this? See, basically I had told you about concave mirror. I had told you about concave mirror and convex mirror and convex mirror. So guys, what are the various parameters I am going to tell you? Basically we have object distance, image distance, focal length, image height, object height. Okay guys, now listen to me very, very carefully. No need to remember this, just listen to me. Concave object is always placed to the left. So object distance is always negative. It is always placed to the left hand side. This is the first sign convention. Image, concave mirror can form image. Can you recall? I had just told you. It can form image both on the left hand side and the right hand side, guys. Recall it. Just recall it. I had told you concave mirror. Can you see? Here image is formed on the left. So V is negative. Here image is also formed on the left. So V is negative. But here it is formed on the right. So guys, here V is positive. Clear? But what about the object? In all the cases, guys, object is placed to the left. That means object distance is negative in each of the case. Are you getting it now? Object distance is negative for each of the case. Clear? Right? So image distance can be positive and negative for concave mirror. But what about convex, guys? What about convex? Can you recall it? Guys, convex mirror always form the image to the right. So that's why for convex mirror, image distance is always positive. Image distance is always positive. Clear? Okay. Done? So image distance is always positive. Focal length, guys. So guys, focal length of concave mirror is negative. As I told you, it lies to the left. For convex is positive. Image height. See, concave mirror can form the image upwards as well as downwards. So image height for concave mirror can be both positive or negative depending on the object distance. But convex mirror is always forms virtual and erect image. That's why it is image height is positive upwards. Right? Object height is positive for all. We never place object inverted. Clear, guys? So this is the sign convention you should be following. Okay, just write it down briefly, guys. Without this, you won't be able to solve the numericals very, very clearly. Clear, guys? Okay. Now, next parameter is magnification. What about the magnification, guys? How can you find the magnification? So, guys, basically, magnification can be of two types. Right? It can be positive it can be negative. Okay, if magnification is positive, guys, so image is virtual and erect. Just recall this, guys. If magnification is positive, image will be virtual and erect. But if it is negative, image will be real and inverted. How is the image, guys? It is real and inverted. Clear? So guys, these are the two things that you should be considering. These are the two things that you should be considering about the sign convention. This is very important slide out of all the slides we have read till now. Okay. Clear, guys? Should I move forward now? Let's do one numerical. Try this question. Question is, a concave mirror produces 3 times magnified image enlarged, obviously real image. The image is real. Okay, and of an object placed at 10 centimeter in front of it. Object is placed at 10 centimeter and image is produced 3 times enlarged and it is real. You have to find the image distance. Try it. Pause and try it. I am about to tell you the solution. See, guys, basically magnification is what? It is 3, but since the image is real, it is -3. I told you, take with sign. What is magnification? It is minus v by u. Okay, so guys, from here minus v is equals to -3u. Cross multiply it. So from here v is equals to 3u. Okay, now what is the object distance? It is 10 centimeter. So guys, object distance is 10 centimeter, but this is not right because take it negative. I had told you, always take the object distance as negative. Is it clear? So object distance is negative. Now put the value here. What is the image distance, guys? V is 3 into -10, so -30 centimeter. This is the image distance V, -30 centimeter. Okay, so in the options you have to tile the magnitude only, not the sign. So A option is correct. It would have been -30, right? Then that option also would have also been correct. Clear? Okay, so guys, this is how you take the sign convention, or sign of V, sign of U, sign of F, right? Sign of object distance, image height, object height, all the signs should be taken into consideration very clearly. Okay, should I move forward now? Clear? Okay, now next part is refraction of light. What is refraction of light? So guys, have you seen phenomena like this? For example, while a pencil is bending into the water, it appears that the pencil is broken, but it is not broken. It appears to you like it is broken. So this is due to refraction of light. Or you can see the arrow is inverted. It is to the right, but it appears to you to the left if you look at the arrow through a glass full of water. So why has this happened? Due to refraction of light. Here also you can see the pattern appears to be changed. The pattern is different while looking through the water. So this is also due to refraction of light. So refraction means the bending of ray of light. When light enters from one medium to another, it bends, its path changes. That is, when light ray is going from air to water, basically it should go like this, but it has bent. So this bending is due to change in medium while a light is going from air to water. So this is known as the refraction of light. So what is refraction? When light travels obliquely. Obliquely means at a certain angle. Obliquely means at a certain angle. When light is traveling obliquely from one medium to another, the direction of propagation of the light in the second medium changes. You can see the direction has changed now. It is not going straight. It has bent by a certain amount. So this change in direction is known as the refraction of light. Light rays refracts whenever there is a change in medium. So in reflection, we did not have a change in medium. Here we have a change in medium. Is it clear? Okay. So the path of the light ray changes, or you can also call like the direction of the light ray changes in case of the reflection of light. Clear, guys? Okay. Now, how does light ray is refracted while passing through the glass slab? See, guys, basically what happens is air is a rarer medium, right? It has lesser density. Glass is comparatively denser medium, guys. So guys, whenever light ray goes from air to glass, from rarer to denser, you can see this is the normal ray at the point of incidence. So light ray has bent towards the normal due to going from denser to medium. But at the second point, it is going from denser to rarer. So it has bent away from normal. Okay. So guys, this is the final ray. This is the incident ray. This is the incident ray, right? This is the refracted ray. This is the refracted ray, and this is the emergent ray. This is the emergent ray. Okay, guys, is it clear to you? So guys, what do you observe? If there were no glass slab, this ray would have gone straight, but due to presence of this, the ray has been displaced by some distance to the left, and this displacement is called lateral displacement. Laterally displaced due to glass slab. There is a formula for that, but you will study this in the higher classes. So this is called lateral displacement. And one more thing, what about the angles, guys? This is angle of incidence, this is angle of refraction, this is angle of refraction, right? And this E known as angle of emergence. So E is called angle of emergence. Angle of emergence, the angle formed by the emergent ray with the normal. So this is called angle of emergence, or I is known as the angle of incidence. I is known as the angle of incidence. Is it clear, guys? Okay. So basically, guys, I had told you light ray bends. This we had seen. But thing is, how does it bend and why does it bend? This is the more important question. Why does light ray bends while going from one medium to another? This is the question. So guys, the answer to this question is refractive index. What is refractive index? See, basically when light goes from one medium to another, okay guys, right? This is the angle of incidence, this is angle of refraction. The speed of light in this medium is v2, here it is v1, here it is v2, because this is medium 1. Let's say this is medium 1 and guys this is medium 2. So here speed of light is v1, here speed of light is v2. Let's say the refractive index of this medium is n1, this medium is n2. So guys, refractive index is a parameter that tells us how much will the light ray bend and how much will the speed of the light ray in that medium. Because guys, light ray does not travel with the same speed in air, in glass, in water. The speed of light is different in different mediums. And why is that? This is because of the refractive index. Clear? Okay. So what is refractive index, guys? Just recall this formula. N1 by N2 is equals to V2 by V1. This is the formula you should remember. Okay. This is the formula you should remember. But what about if the first medium is air? If first medium is air, so guys, N1 will be equal to 1 because the refractive index of air is 1. It does not bend the light ray. And what is the speed of light in air? It is equals to small c, which is 3 into 10 raised to the power 8 meter per second. Okay. So guys, if I put this in this formula, 1 upon N2 will be equal to V2 upon C. So guys, from here what is N2? It is C by V2, or in journal we write N is equals to C by V. V is the speed of light in the respective medium. So what is the this refractive index, guys? Refractive index N is of a medium is the ratio of velocity of light in vacuum, which is C, to the velocity of light in the respective medium, which is V. So N is equals to C by V. N is equals to C by V. C is the speed of light in vacuum and v is the speed of light in that respective medium which you are talking about, right? So guys, you can see refractive index is inversely proportional to the speed of light, or I can vice versa. More refractive index means the speed of light will be lesser. So very denser medium, in very denser medium, light ray travels with the very small speed. Is it clear? Okay. So this is how you relate the refractive index and the speed of light. Very important formula. It will be used later on. Clear? So guys, refractive index of various medium is shown. You can see air has a refractive index of nearly 1. Minimum refractive index for this. But you can see diamond has maximum refractive index because diamond is the densest material. So my bad. Diamond is the densest material, guys. Diamond is the densest material. It has maximum refractive index. So speed of light will be least in diamond. Speed will be least out of all these. Will be least in diamond. In diamond. And how much is that? N is equals to C by V. For diamond, N is 2.42. So guys, what is V from here? It will be C upon 2.42. Right? So just calculate this. 3 into 10 raised to the power 8 upon 2.42. Just calculate this. You will get your answer. Yeah, it's your task. 3 upon 2.4. It will be around 1 point something. So this is the speed of light in diamond. Minimum speed out of all these. And Canada balsam, rock salt, and all these turpentine oil, kerosene, alcohol, they lie in between. So what you have to do, just divide the speed of light in vacuum by the refractive index of any of these, and you will get the speed of light in that medium accordingly. Clear? Is it clear to you guys? Okay, fine. Just try this numerical. Try this. It has been said that light enters from air to glass have a refractive index 1.5. So you have to calculate the speed of light in the glass. So guys, what is N? It is C by V. Refractive index is 1.5. C is 3 into 10 raised to the power 8 upon V. So guys, what is V from here? 3 into 10 raised to the power 8 upon 1.5. This is 2 times. So this will be 2 into 10 raised to the power 8 meter per second. Clear guys? So which option is correct? Option D is correct. Speed of light in this glass. Clear? Done? Should I move forward now? Okay. What are the various laws of reflection, guys? See, like we had laws of reflection, we have laws of refraction also. And what are those laws? First law is the incident ray, the refracted ray, and the normal to the point of incidence of the at the interface of two transparent media. Interface, the boundary separating the two media, right, at the point of incidence, all lie in the same plane, guys. Like I had told you the laws of reflection. All three rays here, all the rays will lie in the same plane. This is incident, this is normal, this is refracted ray. Like a wiper of a car, all will lie in the same plane. Clear? Okay, fine. Now next is what? The ratio of sine of angle of incidence to the sine of angle of refraction is constant for the light of given color and for a given pair of media. Suppose if I take any two medium, guys, so for that particular pair of medium, the ratio of sine of angle of incidence, that is sin I, to the sine of angle of refraction, sin R, this ratio is constant for that media and that light, right? And this constant is called the refractive index of second medium with respect to the first. Now what is this? Let me tell you. Suppose, guys, light ray is going from medium 1 to medium 2. Speed of light is V1, here speed of light is V2. Light is going from this medium, this is normal, to this medium. So guys, this is R, this is I. So guys, what does Snell's law state? Sin I by sin R. This is N2 upon N1. We call it N21. What is N21? This is the refractive index. This is the refractive index of what? Of second medium. of second medium with respect to WRT first medium with respect to first medium. Clear? So N21 we denoted by N21. Clear guys? So what is N21? It is N2 upon N1. But if I ask you N12, so it will be N1 upon N2. That is refractive index of first medium with respect to second. The one about which with respect to which we find comes in denominator, right? So guys, what can you infer from these two equations? That N12 is nothing but reciprocal of N21. Okay, clear guys? Fine. So this is also, this is how it is. Or I had told you one more formula, that N2 upon N1 is equals to V2 upon V1. So guys, these are the basic formulas you should be knowing. Clear? So sin I by sin R is constant, and this is N2 upon N1, which is equals to V2 upon, sorry, V1 upon V2. My bad. V1 upon V2. It is inversely proportional, na? It is V1 upon V2. Okay? It is V1 upon V2. Clear? It is V1 upon V2. Sin I by sin R. This is constant. Okay? So guys, these are the very, very important formulas you should be knowing. Very, very important. You will definitely get a question from this. This is very, very important point, or very, very important slide. Is it clear? Now let's try a question based on this. Read the question guys. Read it. A ray of light traveling in air falls on the surface of a glass slab. The ray makes an angle of 30 degrees with the normal. This is angle of incidence. Let us draw the diagram. This is incident ray. Okay guys. The ray has bent by a certain angle. This is I, this is R, this is N1, this is N2. Okay, this is a diagram, basic diagram. Angle of incidence is 30 degrees. Okay. Find the angle made by the refracted ray with normal. That is, you have to find the R. What is said? The refractive index of glass is 3 by 2. So guys, N2 is 3 by 2. What is N1? It is traveling in air. So N1 will be equal to 1. N1 will be equal to 1. Okay guys. Now use Snell's law. Snell's law states that sin I upon sin R will be N2 upon N1 guys. Okay. I is 30 degrees. Okay. What is R? R you have to find out. N2 is 3 by 2 upon 1. So this is nothing but 3 by 2. Okay guys. So from here guys, what is sin R? If you cross multiply, it is 2 by 3 into sin 30 degree. This is how it is guys. Can you see it? I have just cross multiplied this. So 2 by 3 into, okay, incident ray makes an angle of 30 degree with the normal. Fine. What is sin 30 guys? 2 by 3, sin 30 is 1 by 2. So this is nothing but 1 by 3. So guys, what is sin R? This implies that sin R is 1 by 3. So guys, if I ask you R, it would be sin inverse 1 by 3. This is your answer. I hope you are getting this. This is your answer, sin inverse 1 by 3. Angle of refraction. Clear? So this is how you find, how you apply the Snell's law. This is how you apply the Snell's law. Clear guys? Okay. Now, next part of this chapter is spherical lenses. Guys, what are lenses? Basically, lenses are any, if you find any transparent material, right? If you form any transparent material bounded by two surfaces, so that transparent material forms the lens. So a lens may have two spherical surfaces, right, bulging outwards. Such lens is called convex lens. Bulging outward means, suppose I take two surfaces bulged outward and I fill some liquid in between. So this will form convex lens. Okay. But if I take two surfaces bulged inwards and fill in some liquid of some refractive index, let's say n here, so this will form concave lens. It is bulged inwards. This is bulged outwards. Okay. So bulge outward means convex, and concave lens that is bounded by two surfaces curved inwards, those are known as concave lens. Okay, so guys, you can see convex lens is thick at the middle and thin at the edges, but concave lens, it is thin at the middle but it is thick at the edges, is it clear? Okay, so this is the concave and convex lens. So what are the nature? Guys, convex lens is diverging, I will tell you how. But concave, biconcave lens or concave lens, it is diverging. Convex lens is converging. Basically it converges the light ray. When light ray are incident on it, it converges those light ray to a single point. But what about concave lens? It basically diverges those rays like this. So it spreads the rays, it converges the rays to a single point. Okay, is it clear, guys? So this is called converging and diverging lens. Fine. So guys, like we had in the mirror, we also have some terms related to the spherical lenses. First is, a lens is either a concave or convex lens, has two spherical surface. Every lens has two spherical surface, like I had told you. So guys, see, if I draw any lens, let me tell you, if I draw any lens, so guys, this surface will be a part of a sphere, obviously. This surface also will form a part of a sphere also. That means a lens will be having two center of curvatures. Can you recall it? A lens will be having two center of curvatures, C1 and C2. And as a result, C2, this is C1, two radius of curvature. Both are same here in our case. So lens is formed by two spherical surfaces, unlike mirror, right? So the center of these spheres is known as the center of curvature, the center of this spherical part. Okay, next is principal axis. So guys, what is principal axis? An imaginary straight line passing through the two center of curvature. Can you see it? This imaginary straight line passing through the center of curvature, this is called principal axis. This is called principal axis. Clear? Okay, the central point of a lens is called optical center. This lens has a center known as optical center. Okay, last, aperture. Like we had in the mirror, the effective diameter of the circular outline of a spherical lens, effective diameter, that is the area to take the light rays. Have you seen that you have aperture in your phone also, right? So basically aperture means how much rays does it gather. So for example, if I talk about portrait mode, do you have a portrait mode in your phone? I'm sure you must be having. So guys, in portrait mode, basically it focuses on the subject, it blurs the background, right? So if you want to blur the background, your aperture should be high. Why? Because you want to gather maximum rays from the subject. For example, if I'm taking my picture in portrait mode, so I am the object. The lens wants to take the maximum rays from me, so I have to take the high aperture in portrait mode, right? So so this is the use of aperture if you want to gather maximum rays from the object. Okay, clear, guys? Fine. So next is principal focus. Like I had told you in the mirror, rays parallel to the principal axis falling on a convex lens converge to a point. For example, if I take any convex lens, so guys, rays coming parallel to principal axis, they converge to a point after refraction. This point is called focus, F1. Okay, and distance of this focus from optical center is known as focal length, right? Distance of the principal focus or focus from optical center is called the focal length. Clear? So basically few terms are same as that of mirrors. Okay, now image formation. So guys, like in the mirrors, I also have few rays to use in lenses also. So first ray is passing through principal focus. So guys, I had told you, if you pass any ray through principal focus, or if you take parallel rays, they will pass through principal focus, right? If you take parallel rays. Clear, guys? Or you can also take rays like this. This is basically f1, but if you, this is f1 and this is f2, my bad, this is f2, guys. Okay, so if you pass any ray through focus, the answer is they will become parallel to principal axis. This is the first case. First ray you can take. Second ray passing through optical center. So guys, if you pass any ray through optical center, so basically that ray does not deviate at all. That ray does not deviate at all. It will go as it is, like this, undeviated. It will go undeviated. Clear? Okay, so this is how rays are formed. Fine, guys. Next is parallel to principal axis. I had told you it will converge at focus or diverge in case of convex lens. Fine. Now ray diagram formation, very important part, guys, right? Very important part is how rays are how ray image is formed by convex lenses or by concave lenses. So guys, like we had done in the mirrors, we have in the lenses also. Okay, see, first is convex lens. So guys, first of all, this is optical center, this is focus f1, this is this is focus f1, right? This is f2, this is c2, right? This is f1, this is c1. C1 to the left, and this is the first principal focus, right? Center of curvature. This is second principal focus, right? Or center of curvature. Clear, guys? Now in first case we take ray parallel, that is object at infinity, so they will converge at focus. So here image is formed, right? Object at infinity. So object at infinity. Okay, guys, where is the image formed? At focus, that is at f2. Image is point size, right? Image is point size and it is real. Rays are actually meeting. So image is real and inverted. How is the image, guys? It is real and inverted, right? Next case. Let me draw the lenses first. This is lens, this is principal axis. Just draw like I am doing, you will remember it. C1, F2, C2. Okay, yes, are you listening to me? Hello everybody, are you listening to me? Yes sir. Are you listening to me? Yes sir. Okay, so guys, here the object will come closer to the lens, so image will go away. So here the image, first ray will be like this and second ray will be like this. So this is the image form, this is the image, this is the object. Clear? So guys, here where is object? Beyond C1. Where is image? Between F2 and C2. Okay, are you getting it? It is real image, obviously, real and inverted. You can see rays are actually meeting. And what about the size? Obviously image is smaller than the object, so it is diminished. Okay, we call it diminished. Clear? What about this one? Again the object will come closer, so first ray will be like this. Okay, what about the second ray? Second ray will go like this. So here image is formed at C itself. I want you to draw the ray diagram with this much perfection like I am doing, and this only comes with the practice, obviously. Clear? So where is the object, guys? Object at C1. Where is the image? At C2. And what about the size? Same size. Here the image formed is at same size. when it is placed, when object is placed at center of curvature. Clear? So it is of same size. What about the nature? It is real and inverted, guys. Image is real and inverted. Clear? Okay. Fourth case, this will be fifth case, and this will be sixth case. Okay. Lenses, first draw the lenses. This is O, this is F1, this is C1, this is F2, this is C2. Okay. Draw one more lens like this. Optical center, this is F1, this is C1, this is F2, this is C2. One more lens like this. Okay, so this is O, this is F1, this is C1, this is F2, this is C2. Clear? Okay, now we are done with the lenses. Now object. So object will come more closer to the lens. Earlier it was a C. So again, first ray, it would pass through focus. What about the second ray? What about second ray? Let's take it through optical center. So ray will meet here. Okay, so image is formed beyond C2. Clear? So object between C1 and F1, where is image? Beyond C2. And how is the size now? Is it enlarged? Obviously yes. Object is smaller and image is large, right? So it will be enlarged. It will be enlarged. What about the nature? Are they actually meeting? Yes. Nature will be real and inverted. How much will be the nature? How is the nature, guys? Real and inverted. Now object will be placed at F. So again, first ray it will pass through focus, and for second ray it will pass like this. So again you can see the rays won't actually meet. So where is the object? At F1, we assume they meet at infinity. So guys, image will be formed at infinity. It is also real and inverted. And what about the size? Highly enlarged. Highly enlarged in this case, right? Highly enlarged. Last case, let us change the pen color because it is different. This case is different. First is ray passing through focus, object between F1 and O. Second ray is like this. They won't meet here, but if you back extend them, guys, the ray will meet here. Here, right? So here this is the image, sorry, this is the image, and this is the object. So where is object? This is case is different between F1 and O. Where is the image? We see the distance, thus position is not fixed, though we write it on the same side as the object. Okay, on the same side as the object. Clear? Size enlarge, image is bigger than the object, so image is enlarged. What about the nature now? Are the rays actually meeting? No, you have to extend them. They appear to meet. So here the image is virtual and erect. Clear, guys? Okay, so these were the cases of the convex lens. Now what about concave lens? So guys, for concave lens has only two cases, right? It has only limited number of things or limited number of image formation by the lenses. So guys, for concave lens, first let us draw a concave lens like this. This is first and this is second. Okay, so this is optical center, this is F1, this is C1, this is F2, this is C2. Okay, are you getting it, guys? And what about this? This is optical center. This is f1, f2, sorry, this is c2, and this is f1, this is c1. So guys, in this case, if you place object at infinity, it acts as a diverging lens, as I had told you. So they appear to come from focus. So here guys, object at infinity, image at f1. And what is the size? Point size. The image is point size. And what about the nature? The rays won't meet in actual, they appear to meet. So that's why it is virtual image. The image is virtual image. Clear? What about this? Let's bring the object closer to the lens. So it acts as a diverging one. Now, right? And like this. So you see they won't meet here, but if you back extend them, they appear to meet here. So this is object, this is image. So guys, here object is anyway between optical center and infinity. Image is formed between f1 and O. What about the nature? It is also virtual. Nature is virtual, erect, and size is diminished. Size is diminished. Clear? Okay, so these are the cases, these were the cases of the concave and convex lenses. Fine guys, now like we had in the lens mirrors, we have a same formula in lenses. This is lens formula, focal length, object distance, image distance, but difference is we have a negative here, right? Similarly in magnification, it is the ratio of image height to the object height, and it is also equals to V by U. Here we don't have negative here. Can you notice? We don't have negative here. In mirror we had negative, here we don't have negative. Okay, and guys, sign convention is same. For concave lens we have negative focal length like we had for concave mirror. For convex lens, and we had a focal length is positive light like we had for convex mirror. Okay, object distance is always negative, image distance depends whether the image is formed on the right or to the left. Okay, and magnification is also same. If M is positive, image is virtual. If M is negative, image is real. So in this case, image would be real. In this case, image would be, sorry. In this case, image would be virtual. Okay. Here, the image would be real. Here, the image would be virtual and erect. Clear? So like we had for mirrors, we have same for the lenses. Okay, but here concave mirror, if I talk about concave lens, so guys, for concave lens you can see the image distance is negative. Here also image distance V is negative, right? Because image is always formed on the left hand side. But for convex lens you can see image distance is positive here, right? Here also image distance is positive, but here image distance is negative. So here we have variety for convex lens. There we had variety for concave mirror. Okay, so this is the difference you should be knowing. Clear? Let's do a question on this now. It has been said that an object of height 2.5 centimeter is placed perpendicular to principal axis of a convex lens of focal length 24 centimeter. Focal length is given. You have to find the size of the image if object is placed at a distance of 16 centimeter from the lens. So guys, first of all, let us write the parameters that are given to you. What is the focal length, guys? Focal length is 24 centimeter, and you have to take it as positive because it's a convex lens. Object distance is how much, guys? It is 16 centimeter. Take it negative always, as I had told you. So guys, apply lens formula. 1 by f is equals to 1 by v minus 1 by u, right? 1 upon 24 is equals to 1 upon v minus minus plus 1 upon 16. Minus already is there, minus minus would be plus. So guys, from here 1 by v is how much? 1 by 24 minus 1 upon 16, right? 6 4. And how much will be the LCM for this? Yes, 4 6 4 4 let me find it out. 24, I think it's 48, right? For 12, 12 to 48, yeah, it's 48, right? Just do it if you are having some doubt by your own, right? 48, so it will be 2 minus 3, it will be minus 1 upon 48, right guys? So V is how much? Minus 48 centimeter. Negative because image is formed on the left hand side. Clear? And you have to find the size of the image. So guys, what is magnification? It is HI upon HO. Image height upon object height, the ratio, and it is equals to V by U. Not negative as I had said. Here it is V by U. Here it is V by U. So HI you have to calculate. HO is given as 2.5. What is V? Minus 48. And what is U? What is U? 16 and minus 16. U is minus 16. So minus is cancelled. 16 3s are 48. It's 3. So guys, from here what is image height? 2.5 into 3. 2.5 into 3, it is 7.5 centimeter. Clear? It is 7.5 centimeter. Clear? Which option is correct? Option B is correct. Is it clear guys? 7.5 centimeter. This is how you should apply the mirror lens formula and mirror formula also. Clear? Fine. Okay. So last topic is power of a lens. Last topic is power of a lens. So guys, before starting with power of a lens, let me tell you, like, suppose if I take two lenses, right? If I take two lenses, right, both have a different radius of curvature. So guys, let's say this lens converges rays here, but let's say this lens converges rays here. Right? So guys, what do you see? This lens has more converging ability, isn't it? It converges the rays more converging ability, but this lens has comparatively less converging ability, converging or ability, or diverging ability in case of concave lens. So guys, what do you see? You see that this lens converges more and this lens has lesser focal length. But what about this? This lens has comparatively more focal length. So guys, power tells you the converging or diverging capability of a lens. This is converging more. That means it has more power and less focal length. Can you see this? More power and less focal length. This is converging less, so it has less power but more focal length. That is, both are inversely related. More power means less focal length, less power means more focal length. So guys, this is what power tells you. Power tells you the degree of convergence or divergence of a light rays achieved by a lens is expressed in terms of its power. Okay? Or I had told you it is reciprocal, it is inversely proportional. So you can also call power as the reciprocal. You can also call power as the reciprocal, right? Power as the reciprocal of focal length. P is 1 by F. And what is the SI unit of power? Diopter, we denoted by capital T. Okay guys, so if I talk about concave lens guys, concave lens and convex lens. So guys, what is the focal length for concave lens? I had told you it is negative. For convex lens it is positive. Same goes with the power. For concave lens power will be negative, for convex power will be positive. Clear? Okay guys, now there is a note. Note is you have to convert focal length in meter. In this formula, F should be in meter. Then you will calculate the power. I will make you solve one question, don't worry. Focal length should be in meters. It like if it's 20 centimeter, it would be 20 by 100, 1 by 5 meter. So you have to convert the focal length in meter before calculating the exact power. Clear? Okay. Now question is, sir, before trying this question, what about if I combine more than one lenses? If I combine, let's say, 2 lenses or more than 2 lenses, let's take example. So guys, this is P1, this is P2, this is P3. So guys, obviously the resultant power would be different than each of these. So how do we find the resultant power? Resultant power would be nothing but just add all these with sign. Add these with sign. For concave negative, for convex positive. Or P is 1 by F. So what will be the effective focal length? 1 by F is 1 by F1 plus 1 by F2 plus 1 by F3. Okay. So this is how you find the effective power, where P is the effective power. Is it clear, guys? Yes, are you getting it? Okay. Let's try a question. 2 thin lenses are in contact and focal length of the combination is 80 centimeter. Right? Focal length of the combination, that is P is given as 80 centimeter. Focal length, sorry, my bad. Focal length is given as 80 centimeter. Right? Okay. And if focal length of one of the lenses is 40, F1 is given as 40 centimeter. It is positive, that means convex lens. The focal length of other lens you have to find out. Okay. So guys, just apply the simple formula. I have told you that 1 by F is 1 by F1 plus 1 by F2. Right? 1 by effective focal length is 80 given, 1 by 40 plus 1 upon F2. So guys, from here, what is 1 by F2? It is 1 by 80 minus 1 by 40. This will be 80, 1 minus 2. So minus 1 upon 80. So this is 1 by F2, guys. So F2 would be how much, guys? F2 would be how much? Minus 80 centimeter. This is the focal length of the other lens. Minus 80 centimeter. Clear? Minus 80 centimeter. Now what would be the power of the effective lens? Power of the effective lens of the combination, if I ask you. Power of the combination. How would you calculate that, guys? Just, it is nothing but reciprocal of F. Reciprocal of F, effective focal length. But you have to convert this focal length into meter, I had told you. So it would be 80 by 100. So it is 2 by 5 meter. Okay. So power, effective power is 1 by F, 1 upon 2 by 5, which is 5 by 2, and that is 2.5 diopter, and it is positive. Positive means converging. It is acting at as a convex lens. Clear, guys? So this is how it is. This is how you calculate the effective power, effective focal length and power from individual lenses. Clear? Okay. So guys, this was all about the lenses, the power part, right? So I hope you have got all the concepts very clearly. Fine, guys. So I hope you guys have completely enjoyed the session. We have gone through each and every concept, every formula in very detail. Okay. So just go through this lecture, read it from NCERT, and do let me know, right, in the comment section. You will also be getting DPPs for this lecture, right, just to solve it after it. Okay. So just do comment in case of any query. I will be going through each and every one by personally. Okay. So see you all with the, some next topic, the human eye, right, very soon. Okay. So that's all. Bye, guys. Good luck.